Okay, welcome back to your second intro video for vectors. And we're going to pick up right where we left off, and we are going to draw the parallelogram resultant vector. And remember this one, when you draw the vector, you have, let's kind of go down in the same direction. You have vector A, but remember the tail of this one goes to the tail of the other. So this one is going to have right here, and it's going to go that way. Okay, and if I were to sketch out this way and then that way, so this is also the same distance as B and A. The resultant here is that line in the middle. Okay? And so sometimes, especially in your text, it will give you one vector going this way and another vector going this way, and it wants that resultant instead of positioning the vectors where one is coming off of the other. Okay? It's just personal preference, but a lot of times I think the problems lend themselves better to this form and that method. All right, let's try an example with another type of resultant, and that being when you're just adding or subtracting them. So let's see, I think this is example 2. So if you are given vector W, remember use these greater than or less than signs, let's just pick -4, 1. And let's make up another one. I'll do Z. Trying to do something other than X and Y. Let's go -3, 0. We'll just keep the numbers easy. Okay? Then I want you to find, for example, we could use scalars, what we call it, a multiple here, on the vector of -3W. So that means you simply take the -3, and our vector W is -4, 1, and you simply distribute it to each of the terms. So this becomes vector now with a +12, -3. That's all you're doing. Okay, it's very simple algebra. Another one, let's do a little bit more here. If I do 4W plus Z, all right, then you would take 4 times the W vector of -4, 1, and you would add it to the vector of -3, 0. Very often you have 3 or more vectors here, not just the 2. So when you multiply that, here you would have a -16, 4, plus the -3, 0, and then you're simply adding the A parts and the B parts. So you then would have a vector of -16 plus -3, so you would have -19, and you would have 4 plus 0 of 4. So that would be our resultant vector in that case. So you'll have some where you're just simply adding the terms. First you have to multiply, and then you add. All right, another type of resultant vector will be written not just given to vectors like this, but you can also be written, whoops, can't write this morning. I can't write the word written. Using the magnitude and the direction and I'm just going to say and trig values that you're used to using, mainly sine and cosine. Okay? For example, if I draw here, let's see, if I have this vector shooting out here. Okay, it was comprised of maybe this vector A and this vector B, and that would be the resultant, okay, right there, that vector. And so when you write that, you're going to very often have, you're going to use the sine and the cosine. For example, the A, along the X, so you would take the distance or that length, which remember we refer to as the magnitude, you're going to multiply it by the cosine value. Now our theta is going to come here from the X positive axis for the vectors, and then the B being the Y value, you would have the magnitude times the sine of cosine. All right, and you have this point up here where it has origin, or where it's final. The vector, went this way, came up here, but the resultant was here, and it landed at AB. Okay, so this vector, you can rewrite this vector V as put it in component form, basically. We talked about that earlier being A plus B, but if I want to write it in a different form, you would then take the cosine and the sine, and the magnitude of this vector would be vector AB, and let's write it. Vector AB would be written as, there went my lights again, as the magnitude, the cosine value times the cosine magnitude times the cosine value, and the magnitude times the sine value. Now, since they both have a magnitude, very often you will see the magnitude pulled out. All right, and then you just have the cosine and the sine values of that theta inside there. Now this form right here is another component form of the vector that's using the sine and the cosine. So you'll also be asked to do that. Let me just say a word about that theta. That theta is measured counterclockwise from the x-axis. Let me do an example here that will help. I think we're at example 3. So example 3 says if you want, or I want you to find the component form of a vector given the magnitude of 8, let's say, and a directional angle let's just stick with our 45 degrees. So you would take, just like we did right here, you would take the magnitude times the cosine at 45 and the sine at 45. So let's take 8 times cosine at 45 and sine at 45. So the component form of this vector, that distance at that angle, you would simply then just distribute the 8, and you would have 8 times, you already know what the cosine is at 45, which is root 2 over 2, and the sine at 45, same value, root 2 over 2, and then you would simplify that. 2 into 8 goes 4 times, so you have 4 root 2 and 4 root 2. Okay, now we usually do not go to the decimal. Again, give me the exact values, because usually these directional angles will come right off your circle and you'll know the value. So that would be the component form of this vector given a magnitude and given that angle. Now, let's go specifically and play with the angle a little bit. If I said, find the directional angle, of, let me give it to you in that linear combination form, because sometimes you'll see that. Negative 6i plus, let's make it a positive 2j. All right, and when you see that, so find the directional angle of this vector. You need to right away, just in your head, think, okay, that's really a vector of negative 6, 2 that I'm dealing with. And that vector, because sometimes it's a little hard to see from here, but that you can place on a graph. You know that if you're going, let's come over here real quick. If I'm going 1, 2, 3, 4, 5, 6, 1, 2, I'm right there. So that vector is obviously what we would think of as being in the second quadrant. But if what I want is the angle, I'm looking for the directional angle, and remember for the vector, that's this angle right here. That's the angle I'm looking for that theta. Well, if I then get theta is equal to directional angle, remember we did tangent, inverse tangent of b over a, y over x. So this would be 2 over negative 6, which is the same thing as inverse tangent of negative 1/3. And I'm going to do that on the calculator just to remind you. So we need to make sure we're in degree mode because that's what I want. I want a degree. So we're going to do inverse tangent, right there in blue, of negative 1/3. And it's going to tell me negative 18.4. Well, now that's weird, sort of. If it's negative 18.4 degrees, remember inverse tangent is only defined on the right-hand side of the circle. So it's either going to be a positive acute angle or it's going to be down here in quadrant 4, which is where this is. But I'm not playing in quadrant 4, I'm playing over in quadrant 2. So I want you to remember that sometimes when you get the inverse tangent angles, what you're really getting, all right, is this angle right here. That's the negative 18. That's not what I want. But look at what you have. You just want the other part of this angle of that line, so which is 180. So very often all you need to do is add 180. And you here, in this case, you get 161.6. That is this angle here, 161.6. So sometimes you need to kind of graph it, plot it, and this will be very applicable when we are doing our application problems, especially in January. But you're going to do some of this now as well. But when you have the problems and you have to rewrite, essentially, reconfigure the angle so that it applies to your particular problem. All right, I think that's all we're going to do with regards to introduction to vectors. And then I will make another video that will be better for January when we start doing all of our applications and word problems, and we start we will be on ships and planes and doing all sorts of things when we do those. So, thank you very much. I will see you in class where we will practice this.